Hi, my name is Samuel Mujisha. I am a data scientist specializing in building end-to-end machine learning solutions. Today, I'm excited to share with you this project enhancing customer happiness through AI-powered insights. I'll take you through the executive summary, the business problem, the exploratory data analysis and results, the model building, the feature engineering, the model performance summary. I'll give you a demo of the solution and share with you my lessons and conclusion. In terms of the executive summary, I have been able to develop, test, and deploy an end-to-end machine learning solution to predict customer happiness. The model achieved 73% accuracy, and I deployed this model with a user interface and API in the Hugging Face hosting store. The second thing is that we managed to find out which factors are key to predict customer happiness, and these were the order delivered on time, order delivered as expected, making sure customers order everything they want to order, and improving the performance of the courier. So the problem was that most companies really need to understand customer satisfaction because happy customers means more revenue. Manual analysis is slow and subjective, and therefore the need for machine learning and data analytics solutions. This problem is very, very common and directly applicable in the logistics and delivery domain with e-commerce companies, food delivery, ride sharing, etc. So I had two goals. My first goal was predict customer happiness with data sets of 126 responses on a Likert scale, 1 to 5. The target variable Y having value 0 indicating unhappy and 1 happy customers. And the other variables x1 to x6 showing the different features. Our second goal was to find out which of these features is most important in predicting customer happiness. A quick exploratory data analysis showed that for the target variable Y, the values of 1 and 0 were almost the same. The data was balanced, and this showed that the data is good and very good later on for analysis. In terms of exploratory data analysis results, again we used the heat map, and we didn't find any strong relationships, any not strong correlation amongst the variables. There were some relationships, but they were weak. More exploratory data analysis showed that there is a clear positive relationship between customers scoring 5 for the variables x1, x2, x3, and x5. There's a positive relationship between them scoring highly and customer happiness. The same could go for x4 and x6, only it is weaker than for the previous variables. So we moved on to develop the model, developed 5 models: the logistic regression, random forest, decision tree, support vector machine, and naive Bayes. Later applied grid search CV for hyperparameter tuning while focusing on reducing overfitting. The results showed that the logistic regression model performed the best with a 63% accuracy and an F1 score of 69%. Doing feature selection showed that the decision tree showed that X4 and X6 are not strong predictors to customer happiness as the rest of the variables. This was confirmed by the random forest model as well, showing X4 and X6 as not strong predictors really to customer happiness. So we did some feature engineering and dropped X4 and X6 to stay with X1, X2, X3, and X5, and reduced some outliers in the data and retrained the models. When we trained the models again now, the random forest classifier came out strong with a 73% accuracy and 75% F1 score. So I took this random forest model and saved it using JobLib. I used Docker for containerization, used Flask REST API for predictions, and Streamlit UI for user interaction. Let me show you a quick demo here. This app here deployed right on Hugging Face, and we could see here the variables. Let's say if the customer flags all of them as 5, Says I'm happy with the delivery time that comes to my order as I expected, or everything I wanted to order, and I'm satisfied with the courier and Predict. We say the customer is predicted to be happy with a native 7.4% satisfaction. If we score delivered on time 4, oops, the customer is not happy. They are not happy. They are not happy. They are most likely not happy if we don't deliver on time. Let me see contents of order delivered. They're still happy. Let's see if we've already everything ordered. They ordered everything they want. They are still happy. They are still happy. Let's go ahead and see this one. Courier. They are still happy. So if they score 4 and 5 up, they are still happy. Let's see now if we do this and make it 5 for order delivered on time. Oops, they are not happy. Looks like order delivered on time is the strongest predictor. So you can go ahead and play with this application, and this is very it's available and is very keen on understanding customer happiness more. In terms of challenges, I faced some challenges. The data size was small, so would encourage the company to collect more data so that we can train the models better. And we also saw that the models were overfitting at some point, so very key to balance accuracy with generalization. This project we demonstrated key skills: machine learning and model evaluation, Python and scikit-learn, data analysis and visualization, feature engineering, API development with Flask, UI development with Streamlit, and Docker and deployment. In conclusion, very, very key to do a thorough feature selection with small data sets. Very key to balance model performance with business usability. And we also saw that deployment is as important as modeling. So very key to have end-to-end ownership of machine learning projects. Thank you very much. That's my GitHub link. That is my LinkedIn link. I'm happy to connect with you and help to turn your real-world data for your organization into actionable business impact. Cheers. Look forward to connecting.